Okay, guys, let's talk about transformations. This is our new unit. And the first lesson we're going to talk about is translations, one of the many types of transformations. There will also be a lot of new vocabulary for this unit. Before we start, let's review the coordinate plane. So remember, a coordinate plane is simply a horizontal and vertical number line that intersect, creating four quadrants. Quadrant 1 is in the upper right-hand corner, and this is where all of your positive coordinates lie. Then we are going to go counterclockwise to quadrant 2. So in geometry, going counterclockwise is the default unless otherwise stated. So in quadrant 2, the way we get to quadrant 2, our coordinates are negative, comma, positive. And remember, the first coordinate is x and your second coordinate is y. Then we have quadrant 3, and the way we get to quadrant 3 is the x is negative and the y is negative. And then lastly, we have quadrant 4, and the way we get to quadrant 4, our x is positive and our y is negative. So a transformation is simply just moving a shape or a point on the coordinate plane. And it is called a one-to-one mapping. And we are going to begin with our original point or shape, and we are going to transform it, and it will have different ordered pairs. So you can see here that our original shape, this quadrilateral ABCD, has now moved into quadrant 4, A prime, B prime, C prime, and D prime. So this is an example of a transformation. So the four transformations that we're going to learn in this unit is a translation, reflection, rotation, and a dilation. Now, two of our new vocabulary words is a rigid transformation and a non-rigid transformation. So a rigid transformation simply gives you congruent shape. So if you move a shape, you still have the exact same shape and size. So a rigid transformation, the result is a congruent shape. A non-rigid transformation produces a similar shape. The shape is the same, but is a different size. So they are similar. And here's our notation for similarity, and here's our notation for congruent. So of these four, a translation, a reflection, and a rotation are rigid transformations. A dilation is a non-rigid. Another word for rigid transformation is isometry. And again, you simply preserve the same shape and the size. So you can see here we have a translation where we have slid the blue triangle across the coordinate plane to produce this pink one, still the same size and shape. We can have a reflection, which our blue triangle has reflected across the y-axis, producing a congruent triangle. And then we have our rotation, where we are rotating this blue triangle around the origin to produce the pink triangle. Again, same shape and same size. So translation, reflection, and rotation are rigid transformation. So let's talk about the word pre-image and image. So the word pre-image obviously is before the transformation occurs. So it is your original point or your original shape. And then once a transformation has occurred, you now have your image. So we have A, B, C. This is triangle A, B, C. This is your original called the pre-image. And we have reflected it across this vertical line to produce A prime, B prime, C prime. So if I didn't have these labels, pre-image and image here, the way I know which is the original and which is my new image is the original, the pre-image, has no apostrophes, and we call them primes. And so this is where I know the image originated. So this A prime, B prime, C prime illustrates that this is the image after a transformation has occurred. And we call that notation is simply prime. So this is like P prime. Okay, so we're going to talk about mapping notation and functional notation, but we're just going to get to each of those as we practice. So here you need to make sure you write this down. So now we're totally going to focus on a translation. So translation, you can see this SL, is simply a slide on the coordinate plane. So you can see here in our image is the blue triangle is the original because there are no primes, no apostrophes. And when you translate, we're always going to translate horizontally first, which affects your X values, and then we're going to translate vertically, which affects your Y coordinates. Okay, here's our first example, and we are going to identify the coordinates of our original image. So we have ABC, triangle ABC, and A is 2 comma -3, B is 2 comma -6, and C is 6 comma -6. So this is quadrant 4, again, where we have positive, negative coordinates. And now we have moved into quadrant 2, and these are going to be negative, positive. So let's just go ahead and write down our new coordinate. So A prime is -6, 4. B prime is -6, 1. And C prime is -2, 1. So the question is, what was the rule? How was this translated? How was it slid? And again, we're always going to do the horizontal, which affects our X coordinates first. So the way you write the rule, the notation, we're going to do a big T for translation, and then a superscript. It's going to look like an ordered pair, but it's not. It's just the direction. So the first value is your horizontal shift. So let's take A to A prime. So the triangle was slid 1, 2, 3, 4, 5, 6, 7, 8 units to the left. So that's -8. Then it was slid 1, 2, 3, 4, 5, 6, 7 units up. So this is the rule, -8, 7. And again, that is not an ordered pair, it's just your rule. Now let me show you something that if you didn't have the graph and I just gave you A and A prime, you could simply say, how much did 2 go to -6? What was the change? So if I'm at 2 and I end up at -6, I can see that's a difference of -8. Then our Y value, we were at -3 and we shifted up to a +4, so that went up 7, and you can see that in our rule. So you can find this algebraically as well. Okay, let's do a second example. Now our pre-image is in quadrant 3, which is all negatives. So -7, -1, -7, -4, and we have -3, -4. A prime is going to be 1, 6, and let's just identify we're now in quadrant 1, so our image is in quadrant 1. B prime is 1, 3, and C prime is 5, 3. So let's see if we can find the rule without the graph, and then we can confirm with a graph. So T for translation. So let's find the horizontal change. So it went from -7 and slid all the way to +1, and that's a change of 8. Then we went from -1 up to 6, so that's a positive change of 7. So let's just confirm. So from A to A prime, 1, 2, 3, 4, 5, 6, 7, 8, that checks out. And then up, 1, 2, 3, 4, 5, 6, 7. Very nice. Okay. So now let's do one more and then we'll move on to a different set of problems. So we are starting out in quadrant 2, negative positives, and we end in quadrant 3, all negatives. We're going to write the rule. A is -4, 7. B is -4, 4. And C is 0, 4. So C is on the y-axis. A prime is -4, -4. B prime is -4, -7, and C is 0, -7. So let's take a look. Look at your X values on the pre-image and image. They are all the same. That means our shape did not shift left or right. It just went straight down. So we have 0 movement for our horizontal. It didn't go left or right. It just slid down. And so it went from a 7 to -4, which is a change of a -11, or you could physically count this. Okay, now they're giving us the rule, and we have our pre-image. So let's identify these coordinates. So we have 1, 6. We're in quadrant 1. 1, 3, and 5, 3. We are going to move left 6 and down 8. So we can do it graphically first, and then I'll show you how you can do it algebraically. So we're going to go left 6, 1, 2, 3, 4, 5, 6, and down 8, 1, 2, 3, 4, 5, 6, 7, 8. So then don't forget to do A prime. Make sure you label it correctly. And then we're going to go again left 6, 1, 2, 3, 4, 5, 6, and down 8, 1, 2, 3, 4, 5, 6, 7, 8. That is B prime. And then C, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. And then connect to create the triangle. Triangle A prime, B prime, C prime. So this is going to put us at A prime, -5, -2. We are in quadrant 3. B prime, -5, -5. And C prime is going to be -1, -5. So the other way you could do this algebraically is simply take your rule and write it underneath the appropriate coordinate, and then just add those together. So 1 plus -6 is -5. 6 plus -8 is -2. And you just do that for each of these. So that's what we're going to do here. So our pre-image, A is going to be -7, 1. B is -7, -2. And C is -3, -2. So we are going to apply. So this X coordinate is going to move to the right 9, and the Y is going to move down 4. And when we combine those, A prime is going to be 2, -3. So 2, 1, 2, 3. This is going to be A prime. Then we have 9 and -4 for our B coordinate, and this gives us 2, -6. So 2, -6 is B prime, and C prime is going to be 6, -6. So 6, -6 is C prime. And then let's connect those. Okay, let's try another one. So we have A in quadrant 4, 3, -3. We have B, 3, -6. And C is 7, -6. We are shifting this triangle to the left 8 and then up 8. So sometimes you may not have a graph, and that's okay. This is pretty easy, just combining those values. This gives us -5, +5 for A prime, -5, 2 for B prime, and -1, 2 for C prime. So let's plot these. -5, 5, that is A prime, -5, 2 is B prime, and -1, 2 is C prime. And if you didn't make that exact triangle, that congruent triangle, you know that you did something incorrectly. So now we are in quadrant 2. Okay, so we're going to apply what we just did. I'm not going to use this graph at all. So we have X, 5, -3, and this is in quadrant 4. And we are translating it 6 units left and 2 units down. Okay, so when we combine those, X prime is -1, -5, putting us in quadrant 3, where we have all negatives. Y to Y prime is moving to the right 9 and down 7. So this gives us Y prime of being 4, -4. So 4, -4 is in quadrant 4, and we started in quadrant 2. Z is in quadrant 4, and we are moving Z to 5 units to the right and 8 units up. So that puts Z prime at 6, 4, which is in quadrant 1. And I hope this helps.